All right, this is our last set of notes for chapter 8. We're going to get to work with roots. Being that we've done a lot of work with our complex polar numbers and our complex rectangular, this is just an application, an extension of the information we've been working with, and it's presenting us with a new formula to determine the nth root of a value in that sense. So here's the initial information that you'll need. W equals z to the nth power. And if we solve for z, then I would need the nth root of w. So we're looking for those nth roots. Our formula that will calculate for us is to take the nth root of our r value times, notice this is our complex polar situation. You notice cosine, I sine, the cis. And so where it looks crazy complicated is in the angle position, but it's really not that bad. We've got theta plus 2k pi, or if we're in the degree mode, we will just take k times 360 all over n, the root number we're asked about. Do the same thing for sine. And then notice here's our values of k. The first one we'll be using would be 0. Then we'll reuse this whole formula all over again, but with k value of 1. And use it all over again for the k value of 2 and recalculate. And then if you needed fourth roots, fifth roots, and so on, you just keep using the sequential order of the k values starting at 0. So we've been in particular being asked to use the cubic roots of -1 plus radical 3i. So they have provided us with the complex rectangular number. So notice that is x plus yi notation. Our first order of business is just to convert to complex polar form. Remember that form is r equals, I just said that wrong, z equals r cis theta is what we've been using. Okay, so we'll have to calculate r and we'll have to calculate theta. Remember, r is simply plus or minus square root of x squared plus y squared. So let's go ahead and do that. I can see that x value is -1. And radical 3 is representing y. Square each of those under the radical. That gives us 1 plus 3. So we've got plus or minus square root of 4, which is really just plus or minus 2. Okay, go ahead and start working on finding theta next. Theta equals inverse tangent of the ratio y over x. Our particular values are radical 3 over -1. That's definitely related to the unit circle, so I don't need to grab a calculator for this. And that would be quadrant 2. That's going to be a multiple of 60, so 120 degrees for quadrant 2. If you want to jot down the quadrant 4 angle, that would be 300 degrees. Okay, now putting that all together to create our complex polar version of our original problem, my r value is 2, cis. And then what I want to make sure I've thought about is the fact that these numbers, for x, it's negative, and for y, it's positive. That refers to quadrant 2. So I need to make sure my complex polar information I'm matching up together will still represent quadrant 2 as well. So if I pick 120 degrees, that happens. Because 120 degrees lands in quadrant 2, matching it up with a positive r value keeps you in quadrant 2. Okay. All right. So next thing we are ready for, let me rearrange my work a little bit here. I've copied the formula, so we don't have to keep scrolling up and down. But the next stage in our process is to actually use our formula. To find the nth roots. Okay, so we know 2 cis 120 degrees. That's what we're working with. Remember, they asked for the cubic roots. So we've got implied information by both of those. R is 2, theta is 120, cubic roots, that is telling me, and my index is 3. So now it's just a matter of substituting. The first time through, you will always let k equal 0. That's how you will always get started when you're using this formula. So if k is 0, then I've got my nth root of r. My nth root is 3, r is 2. Open my parentheses. We've got cosine of theta, which is 120 degrees, plus, since I'm in the degree mode, I need my k value, which is 0, times 360 degrees. And that is all over n, which of course is 3. And notice the I sign term is going to be using the exact same numerical expression we just used for the cosine term. So that's 120 degrees plus the k value 0 times 360 degrees all over 3. Close it up. So now it's just number crunching. Just simplify what we have. I've got the cube root of 2 recopied. This is going to be cosine of, let's look at this, 120 degrees plus 0 times 360. So 0 times 360 is 0. We're left with 120 divided by 3, which results in 40 degrees. And as you notice, the same thing's going to happen over here with the I sign term. That is also 40 degrees, which means we can collapse this a smidge more. So the cubed root of 2, can't make my 3 look very good. There we go. Cube root of 2, cis, 40 degrees. I'm going to box that. That is one of my cubic roots. Okay. I kind of mismanaged my space here, but not a big deal. We can extend the page. All right. We have to go through and use this formula 2 more times. So we have a total number of 3 roots determined. So the next time I just go sequentially, I am letting k equal 1. That's the only update. Everything else will remain the same. So recopy cube root of 2. Open your parentheses. We've got cosine of 120 degrees plus 1 for k this time times 360 all over 3, the n value. Plus, of course, I times sine of 120 degrees plus 1 for k times 300 degrees all over 3. And then you just work on simplifying. So 120 plus 1 times 360 gives you 480. You need to divide that by 3. And that results in 160 degrees. Okay, and since that's the exact same expression, I sine is of 160 degrees as well. So you're going to shrink that back into your cis notation. Cube root of 2, cis 160 degrees. I'm going to box it because that's the final answer. So we've got our first cubic root, our second cubic root. Now we'll generate our third one. So again, this time I am letting k equal 2. Using the exact same formula. Remembering r is 2, n is 3, theta was 120 degrees. I'm just copying those down since they're off my screen right now. Okay, formula-wise, cubed root of 2, parentheses, cosine of 120 degrees for theta plus 2 times 360 degrees all over the n value 3 plus I sine of that exact same expression. 120 plus 2 times 360 all over 3. Now it's the number crunching time. Probably grab your calculator to help you out so don't make any silly mistakes. 120 plus 2 times 360, that gives you 840. And then divide it by 3. That result is 280 degrees. So I've got cosine 280 degrees. I know that would then be plus I times sine 280 degrees. And I'm going to simplify one last time. Cube root of 2, cis, 280 degrees. Okay, so what are in my boxes? Those are the cubic roots of the original problem, -1 plus radical 3i. Okay, so just to kind of go back over our steps. When you're finding any type of roots, it's always best to make sure you have the complex polar form. If not, then it's your job to figure that out first, and then you can use the formula afterwards. With the formula, it will never change. The only thing that can be slightly different is the mode, but you have the process given to you if you end up needing to use the rating mode versus the degree mode like we just did. So once you have that complex polar form, you can easily identify what is R and theta. The prompt of the problem tells you what kind of roots you're finding so that you know how many k values to use. So I use k equals 0, followed by k equals 1, followed by k equals 2. So notice that's a total of 3 k values I used. That matches the type of roots requested. All right, let's try another one. So here we are asked to find the fourth roots. I'm going to pause and copy over that formula again so you guys don't have to keep scrolling. Okay, so I've got it copied for you. Like last time, I gave you a complex rectangular number. Therefore, it's our job to go ahead and convert it to complex polar. So you have x plus yi. I could see my x value is -8. My y value is -8 square root of 3. Okay, remember we need to calculate r. Plus or minus the square root of x squared plus y squared. So we have plus or minus square root of x squared. We've got -8 quantity squared. Y is -8 radical 3 quantity squared. Be careful with your calculations here. I could see making mistakes with the negatives and just having to square that -8 radical 3. So be careful. And that first one is 64 under the radical. And then -8 squared, that'd be positive 64. Radical 3 squared is 3. So 64 times 3 for that term is 192. Okay, add that to this first 64, and we get plus or minus square root of 256. I hope you recognize that is one of our perfect square roots, which is simply plus or minus 16. Okay, now it's our job to determine theta. So theta equals inverse tangent of y over x. It looks like it might be kind of ugly, but I think it's going to simplify for us quite nicely. So y is -8 radical 3. X is -8. So notice those -8s are gone, leaving us with inverse tangent of positive radical 3. That's definitely related to our unit circle. Let's continue to work in our degree mode. So 60 degrees corresponds to that, as well as 240 degrees in that third quadrant, where tangent is also positive. And then we should pause because we haven't talked about it yet. We need to consider the fact, where is this rectangular number located, this complex rectangular number? I'm noticing my x value is negative, my y value is negative as well. So that was quadrant 3. Therefore, I make sure when I pick my r, cis, theta values, the final result is in the third quadrant. Okay, again, like I said last time, I like to try to choose positive r values on purpose so that it just kind of minimizes the number of negatives we deal with. So 16 cis, if I need to be in quadrant 3, then I would pick 240 degrees. Okay, because 240 degrees will make me be in the third quadrant, which is the correct quadrant. Positive r value will let me stay there. Okay, so there is our complex polar number that we'll utilize to get the problem started with finding our roots. So notice I said fourth roots. Okay, that's telling my n value is 4. So let me just write a little list. For fourth roots, We know n is 4. We already found that r is going to be 16. Theta is 240 degrees. Okay. And then now we will just use our formula. The first time through for k is 0. All right, so I've got my nth root. So that's my fourth root of 16 times cosine of theta, which is 240 degrees, plus the k value 0, which is times 360, all over n, which is 4, plus I sine of that exact same expression. 240 degrees for theta plus 0 for k times 360 all over 4. All right, so fourth root of 16. This is something that we can figure out. Remember, a fourth root is asking you what times what times what times what is 16. And that simplifies down to the number 2. And then take a look at your angle information. We'd have cosine of 240 plus technically 0, because 0 times 360 is 0. So 240 is going to be divided by 4, which the result is 60 degrees. We've got cosine of 60 degrees there. Plus I sine of, it'll be the same thing, 60 degrees, which means you can simplify this down to 2 cis 60 degrees overall. So that is the complex polar form of the first fourth root. Okay. Now I'm going to let k equal 1 and just reuse the formula all over again. So fourth root is 16 times cosine of 240 degrees plus 1 times 360 all over 4 plus I times sine of the same expression and work on simplifying. Fourth root of 16 is always going to be 2. And then that is times cosine of, we need to take on your calculator, 240 plus 360. That gives you 600. Divide that by 4, and we end up with 150 degrees. Plus, let's see here, I times sine of. That's going to result in the same angle, 150 degrees. And shrink that down to the shorthand polar notation, 2 cis 150 degrees. Now we have 2 of the 4 fourth roots required by the directions. So now I'm going to just go sequentially with my k value. I will now use k equals 2. So I've got the fourth root of 16 times cosine of 240 degrees, because that's still theta, plus 2 times 360 all over the n value 4. And I sine of the exact same expression. Simplify. So fourth root of 16 is 2 times cosine of, grab your calculator for a little help, 240 plus 2 times 360. Up in the numerator, that gives you 960, and make sure you don't forget to divide that by 4. So that simplifies all the way down to 240 degrees plus I times sine of the same angle value. Okay, shrinking that a smidge more, so 2 cis 240 degrees. Let's see what colors have I used. I'll switch to green next. So I have 3 of the fourth roots determined. 1, 2, 3. Now we'll do the last one. So my k value will be 3. Got the fourth root, 16 times in parentheses cosine of 240 degrees plus 3 times 360 all over 4 plus I times sine of the same expression. Fourth root, that's still 2 times in parentheses cosine of, little calculator help, 240 plus 3 times 360. That's 1,104 degrees. Whoops, I think I just didn't type a number in. Let me try that again. 240 plus 3 times 360. That's 1,320 degrees. Divide that by 4, and you should get 330 degrees out of that. Of course, that's plus I times sine of 330 degrees as well. And shrinking it a little more, one last time, 2 cis 330 degrees. Okay, let me shrink this page so you can see all of it, hopefully. There we go. So things to just kind of point out. They gave us a complex rectangular number, which is not friendly for our formula. Therefore, we first take the time to convert it to complex polar form. And then just using the formula, each time we start off with k equals 0 first and continue to using the next sequential k value until we would have the same number of answers as the amount of root number that they had given us. So fourth roots, I have 4 answers here. If for some reason they asked you to make sure your final answers were in rectangular form, I would just go ahead and expand each of those, like the 2 cis 60 degrees, my first fourth root we found. 2 times cosine 60 degrees plus 2 times I sine 60, plug in my unit circle values and get it back into the x plus yi format. So unless they tell you to do that, don't spend the time on that. All right, one last thing we'll take a look at. Solving. So using solving skills and how this root formula can help us out. So we've definitely learned methods in Algebra 2 for this. And so we're just learning another method as far as that goes. So let's see here. To get it started, what we're going to end up doing is isolating x cubed. So we'd add the 8 over. And then think about this in terms of a complex rectangular number. This is 8 plus 0i. Okay. The next thing we would do is take this information and convert it to polar. Okay. So in order to do that, then I need my r value. So remember that is plus or minus square root of x squared plus y squared. And from my work here, I can see that x is 8 and y is 0 when I want to plug numbers in to calculate r. So we've got plus or minus 8 squared plus 0 squared. That's really going to be r equals plus or minus the square root of 64, which I know is plus or minus 8. So I'm just going to write that down. Okay, of course we need theta. So theta equals inverse tangent of, our ratio is y, which is 0 over x, which is 8. So we're calculating inverse tangent of 0. That occurs at actually 0 degrees as well as 180 degrees. So combining that information together then, we need to determine what's the correct pairing of information for our polar form. Here's something that can help you out. Like if I were to graph 8 plus 0i in the coordinate plane 8's my real number, so I'd go 1, 2, 3, 4, 5, 6, 7, 8. And since the complex direction is 0, I stay on the x-axis at that location. So as I am considering that, then my r-cis theta value, I always like to keep my r value positive. It's just my habit when I do these problems. And then the correct angle, if I'm going to need to stay in my positive x-axis, my correct angle is actually the number 0. Okay, so there's my complex polar form. Now that we have that, and we are solving, here's the deal. This is just kind of a refresher from Algebra 2. When you're solving a polynomial equation that you need to look at the degree. So like this is a third degree polynomial equation. The degree number tells you actually how many total solutions you're going to end up having. Now, some of those solutions might be real. Some of them might be complex, but it gives you the total number all the way. So using our new formula then, as we work through that, let me pause it and put the formula in our work so you guys have it all together. Okay, so I've got that formula copied over one more time. We need 3 roots. So k equals 0 will be our first one. That would be the nth root of r. N is 3 for us. So we have the cubed root, or my r value is 8. And then we end up with, and I'm going to go ahead and shrink this down to my cis notation because I know it's going to end up that way anyway. So cube root of 8, cis for shorthand notation, theta is 0 degrees plus the k value 0 times 360 all over our n value 3. So cube root of 8 is actually 2. Cis, 0 plus 360 is 0. 0 divided by 3 is 0. So we have 2 cis 0 degrees. I'm going to box that. As I keep going, my next k value is 1. So that would be the cubed root of 8. Cis, theta, which is 0 degrees, plus 1 times 360. Divide that by 3. So cube root of 8 is 2. Cis, well, 0 plus 360 is 360. 360 divided by 3 is 120 degrees. So notice when I go directly to my shorthand polar notation, it really doesn't take much space. It just gets the job done pretty fast. Okay, one more time. K is 2, so we can get the third root that's required. So we've got cubed root of 8, cis, 0 degrees is still theta, plus the k value 2 times 360 degrees, all over 3. Well, 0 plus 2 times 360, I know is 720. Divide 720 by 3. So now I have 2 cis, 240 degrees. Okay. Now, I am going to go ahead and jot down. You can do the actual calculations on your own. The rectangular version of these, because I think it warrants a little, it's a good thing to realize because all your work prior to this class has always been in the rectangular form. So that's what you're going to be most accustomed to looking at. So if we take a look at 2 cis 0 degrees, that is 2 times cosine of 0 degrees plus I times sine of 0 degrees. Well, cosine at 0 degrees is 1, so that is 2. I times sine of 0, well, sine of 0 is 0. That just gives us the real number 2 overall. Likewise, 2 cis 120 degrees, that is 2 times cosine of 120 degrees plus 2 times I sine of 120 degrees when I put it in the expanded form. And then using unit circle knowledge, cosine at 120 is negative 1/2. And of course, sine at 120 is radical 3 over 2. I just left my I out. Let me put that, I'll just put it at the end to make it easier. And 2 times negative 1/2, we get negative 1. That second term, the 2's cancel, so I have negative 1 plus radical 3 times I. I'm going to box that. All right, this last one, if I work on it, changing it over to rectangular, we've got 2 times cosine of 240 degrees plus I times sine of 240 degrees. Again, plug in your unit circle knowledge, cosine at 240. What does that give us? Negative 1/2. I times sine at 240. Negative radical 3 over 2, which then is negative 1. Whoops, I forgot to multiply my 2 right here. I just saw I left that off. 2i times sine of 240. So 2i times negative radical 3 over 2. We get those 2's to cancel, leaving us with a negative term. So negative radical 3i. All right. So there's our 3 strategies. Okay, I'm going to take a little bit of time. You can fast forward if you don't want to listen to it. But I want to show you, because I want to particularly remind you what we did back in Algebra 2 real quick to solve the original equation, x cubed minus 8. So just bear with me. So back in Algebra 2, if we solve x cubed minus 8 equals 0, we would apply the SOAP formula. This is a difference of cubes. I have x cubed minus 2 cubed. And so if I use my SOAP formula, my first factor is x minus 2. My second factor is a quadratic, x squared plus 2x plus 4 set equal to 0. Where SOAP comes in, that helps me check my operations. S is for same sign, O is for opposite sign, AP is always positive. So same sign, that means I have the same operation as the original problem, which is minus. Opposite sign would have to be addition, and always positive, of course, is plus. Okay, so as I continue this, whenever you have factors, you set them equal to 0. Well, x minus 2 set equal to 0 gives us the first real solution at x equals 2. So remember, we had that. That was the first one when I took our complex polar and converted it back into complex rectangular. It simplified to just the number 2. Then my other factor happens to be quadratic, and it's a quadratic that you will notice I don't have factors of 4 that add up to the middle term's coefficient 2. So this is where you'd go rely on your quadratic formula. If I use the formula, that'd be negative 2 plus or minus square root of b squared, so that's 2 squared, minus 4ac, so minus 4 times 1 times 4, all of which is over 2 times a is 1. Now, as I work on simplifying that, I have negative 2 recopy, plus or minus. Under the radical, we have 4 minus, looks like 16, all over 2. So I'm just taking baby steps so I don't lose anybody. Negative 2 plus or minus. 4 minus 16, of course, is negative 12. As I work on square root of negative 12, what that is technically equal to, I can factor out the square root of negative 1. I know 4 is a perfect factor of 12. And of course, 3 is the other factor that's not perfect. Okay, so the slow progression here is recopying negative 2 again, plus or minus. Square root of negative 1, I rewrite as I. 4 is 2, and then we've got the radical 3 there. Now, this is all over 2, so I don't have to rewrite again. I'm going to show you that each piece of the numerator gets divided by 2, which now lets me just simplify one last time. Negative 2 divided by 2 makes negative 1. Plus or minus, those 2's cancel. So this is plus or minus radical 3 times I. Now go look at those complex rectangular answers that I had converted for you. And, whoops, I went the wrong way, sorry. We've got them. So, new process using this new formula for complex polar form to help generate the particular roots of interest versus the Algebra 2 method. All right, I highly recommend on our last problem, pause and try to solve it all the way out yourself. And then restart the video, or not restart, but just resume the video and check to make sure we've got matching answers. Okay, first order business, change, or do a little rewriting of your problem. So remember, we would move the 16 over, so x to the fourth equals negative 16. Think of that as a complex rectangular expression, negative 16 plus 0i. And then take that and let's determine the complex polar form. So what do we know? We know that x is negative 16. We know that y is 0. Calculating r, plus or minus square root, that is negative 16 squared plus 0 squared. So r equals plus or minus, see here, square root of, 256, I believe? Let me double check that. That, which is perfect, so r equals plus or minus 16. Okay, and then of course theta is equal to inverse tangent. Our y value is what? 0 over negative 16. So that occurs at 0 degrees as well as 180 degrees. Okay, putting this all together then, remember if x is negative 16, that's over here on the negative side of the x-axis. So when I'm picking my r value and my theta, I want that to land in that kind of position, that exact same position. So I'm going to use 16 cis. I'm going to have to pair that with 180 degrees. 180 degrees will make me get to the correct location. Positive r value will allow me to stay there. Okay, so 16 cis, 180 degrees. All right, now that we have that, we will utilize our formula. So one last time, I'll copy the formula so it's right in front of you. Okay, just making sure things don't swim around on me. All right, we are ready. So getting that started, I need the nth root of r. Well, because this is degree 4, n is 4 for us. So, let me also remind you, first time through, k equals 0. So, nth root, fourth root, r was, where is it, 16. I'm going to use my shorthand notation, cis of theta, which we had as 180 degrees, plus I times, I just said that wrong, theta plus, what do we need, k? K was 0 times 360 degrees, all over the n value 4. All right, so a little number crunching. This will end up giving us 4 through to 16, I know it's 2, cis, 180 divided by 4 is actually 45 degrees. I'm going to box that. And then I keep going, let k equal 1 this next time. We've got the fourth root of 16. That is times cis of 180 degrees plus 1 for k times 360 all over 4. So now we have 2 cis, 180 plus 1 times 360 gives you 540, and divide that by 4. That result is 135 degrees. Okay, k equals 2. So 4th root of 16 cis, angle expression 180 degrees plus 2 times 360 all over 4. 4th root of 16, still 2, cis, 180 plus 2 times 360, I know that is 720. That's 900 Make sure you divide that by 4, and our result is 225. Okay, so now we have 3 of the fourth roots. So those are representing 3 of the answers to our equation. I need to go one more time to get the fourth one. So k is 3 for this round. So we've got the fourth root is 16, cis 180 degrees plus 3 times 360 all over 4. So 180 plus 3 times 360, that gives you 1260. Divide that by 4, 315. So 2 cis 315 degrees. Okay. All right. I'm going to go ahead and jot this down just so that you have it in your notes. If you needed the rectangular version of these, then the first one would convert back to radical 2 plus radical 2i. The second one would be negative radical 2 plus radical 2i. For the third one, negative radical 2 minus radical 2i. And the last one, positive radical 2 minus radical 2i. And you might pause and think about things for a minute about how they should hopefully make sense. First off, in the polar, complex polars, look at where my pen cursor is right now, in the hot pink boxes. Notice the pattern for the angles. The first one was 45 degrees. That's quadrant 1. The second one landed in quadrant 2, 135. And then we continued using the multiples of 45 degrees. Also take a look at the complex rectangular in the dark blue ink that I have written. Notice the x value. So remember what these are representing. Let me find another color here. X plus yi. The x value in quadrant 1 is positive. The y value in quadrant 1 is positive. Notice for the quadrant 2, where we had 135 degrees in the polar format, the x value is negative, the y value is positive, just like they normally are in quadrant 2 for x and y. Look at quadrant 3 as well. Both of them are negative. In quadrant 4, x is positive this time. The y value is negative, which matches up with quadrant 4 behavior. So we can use some of our old patterns there to help kind of know what's going on or check for reasonableness. All right, that wraps up this lesson. So go ahead and do the assignment that goes with it that is on your homework sheet.